Sorry, it took me a couple days to get this up. It's been a busy week, but here we go. So for those of you who missed the class Monday, we went over decision analysis, and I have a case here that is on orthodontist office. This was for you, Amber. So I tried to come up with a scenario where a company is contemplating, sorry, I'm out of breath, I just came up the stairs, a 3D dental imaging machine, and they can either buy a used one, a new one, or keep their existing machine. And one thing with buying a used one is there's a 40% chance of having a repair that will cost $25,000 in the first 3 years. Now, why would they buy this machine? They expect, if there's high demand for it, their excitement for 3D images of their teeth, they'll get $155,000. If that's lukewarm excitement, they'll get $95,000 in additional sales. And if excitement is low, they'll get profits of $35,000 in addition. The probability is 20% high demand, 60% lukewarm, and 20% for low demand. And we build a decision tree. So you don't have to build this and turn in an actual decision tree, but I want you to solve the answer with estimating or with finding the expected monetary value. And I will show you how to do that with this decision tree. We need to do a couple things. First, we need to calculate the repair odds. So here you would just say 25,000 times 0.4, I believe, was my 40% chance of having a repair. So repair yes is that. Repair no, you would have, well, you don't have to calculate it because you already know it's going to be $0 at times 60% chance of having no repair. Now, high demand, there was $155,000 at 20% chance of that happening. For medium demand, it was, I am still out of breath, I'm sorry, 95,000 times 0.6. And then for low demand, it was 35,000. 35,000 times 0.2. And then you have to calculate the cost of this. Buying used was negative $45,000. So buying new is pretty much the same thing, except it's negative $65,000. And these values over here will remain the same for this. So let's just copy U and paste it. No, it's just if you wanted to actually draw it, you could do this. So you've already calculated the demand, so that remains the same. So what you'll need to do is you would take 35,000 times 0.2 plus 95,000 times 0.6 and 155,000 times 0.2, and then you would add to that, or I'm sorry, you would subtract to that the cost of a repair, which is 25,000 times 0.4, and then you'd subtract from that the 45,000 to buy it used, and you would get an estimated expected monetary value for buying used, and then you'd also have a expected monetary value for buying new. You'd compare those two, and you'd do the one that gives you the most money. And I will post the answer to this problem in Canvas.